Okay, guys, let's take a look at number 2. We have the graph of function f of x equals square root of x, which is already graphed for us over here. Then they asked us to obtain the graph of function f of x equal to square root of x minus 4. So they want us to use a transformation. So let's see what kind of transformation this is going to make. Now remember, when something is on the inside, as you can see here, the minus 4 is in the inside of the function. It's part of the function, meaning it's under the square root. So you would look over here, when something is part of the function, meaning inside of the function, it's a horizontal translation, meaning it moves left or right depending on the sign. If the sign is plus, you move left. If the sign is minus, you move right. So when the constant is in the inside of the function, it's part of the function, you're changing your y values, right? Your y values are being affected, right? Your y values are, since your y values are being affected, we're moving across the y-axis, which is horizontal. So hence why you move left or right. If it's plus, you move left. If it's minus, you move right. So let's take a look at some examples. So here we have our function f of x equals the square root of x. Then let's see what happens when we have something like this, where it's a square root of x minus 4 on the inside. So since minus 4 is in the inside of the function, this is going to be a horizontal shift. And in this case, since it's minus 4, we move right 4 units. Now let's just write down a different couple examples, right? Let's say we have f of x equal to the square root of x minus 4 on the outside. Okay, so now if you notice, the minus 4 is on the outside of the square root. Since it's on the outside of the square root, here what we're doing is we're taking the square root of x and then we're subtracting 4 from it. So we're changing our x values, meaning it's going to be a vertical shift. Right? We're moving on the x-axis because we're changing the x values. And here, depending on the sign, we move up or down. So since it's minus, we move down 4 units. Okay? So these are the two different ways, okay? So if it's on the inside of the square root, it's a horizontal shift. Minus moves right, plus moves left. If it's on the outside of the function, okay, it's not inside, we're going to move vertically. And if it's minus, we move down. If it's plus, we move up. So for example, if it was, let's change both of these to plus. Okay, now same thing, since it's on the inside here, a square root of x plus 4, it's on the inside, we're still moving horizontal, but since it's plus, we're going to move left. And over here, since now it's a plus, we're going to move up, right? Plus 4 is on the outside of the square root, so it's going to be a vertical shift. So now let's go ahead and graph it and see how they look. Okay, so let's go ahead and graph. So here we have the square root of x. Then we're going to graph the square root of x minus 4, and let's see what happens. Okay, so the original graph is the purple one over here, our graph of square root of x starting at 0, 0. And then our gray graph over here represents g of x, which is the square root of x minus 4. And let's see the difference, what happens. So as you can see, we moved to the right 4 units. Okay, we moved right over here. This is the function square root of x, and then this one's x minus 4 under the radical, right? Every point gets moved 4 spaces to the right. Every point goes 4 spaces to the right. Right here, this point goes 4 spaces to the right. All the points go, you see, 1, 2, 3, 4. All the points go 4 spaces to the right. 1, 2, 3, 4. Okay? Now let's see what happens. Let's do a couple different ones, okay? Now let's see what happens if our graph was plus 4 on the inside. Okay? So as you can see here, plus 4 moved the graph, plus 4 on the inside, remember we're still talking about the inside of the square root, moved to the left 4 spaces. You see how if it's a plus 4 and it's in the inside of the function, we move left 4 spaces. Now let's see what happens when we take the 4 outside of the square root. So we have square root of x plus 4. Let's see what happens. See? Now the graph moved up 4 spaces. Since the plus 4 is on the outside of our constant is on the outside of the radical, we're moving up or down. And we move up in this case because it's plus. So we move up 4 spaces. Now let's see what happens if it's a minus. We're going to move down. As you can see, this is our original graph, and the new graph, our transformation, moved down 4 spaces since minus 4 on the outside of the radical. Great. Now let's move on. Number 3. So for number 3, we have the graph of f of x equals the absolute value of x, so our typical V shape starting at 0, 0 for absolute value. And they want us to obtain the graph of f of x equals negative absolute value, okay? So now when it's multiplying by negative, as you can see on the outside, when we have a negative being multiplied by the function, we're going to reflect it over the x-axis, okay? Because you're changing the x values here, right? For example, whatever x is, whatever the absolute value of x is, then you're multiplying it by a negative. So you're changing the signs of the x, right? So you're changing your x values. So you're going to be moving across your x-axis. And in this case, we're going to be reflecting over the x-axis. So, and if we're multiplying by negative on the inside, we're multiplying the x by the inside, then we're going to reflect over the y-axis because your y values are changing. So let's go ahead and take a look at some different scenarios. So we have our f of x equal absolute value of x. Then we have f of x equals the negative times absolute value of x. Now, since we're multiplying a negative on the outside, this is going to reflect over the x-axis. Okay? Because you're changing your x values here. You're taking a positive x and you're multiplying it by a negative, so you're changing your x values, meaning you're going to be reflecting over the x-axis. Okay, so here we're going to be reflecting over the x-axis. Even if it was something that looked like this, like a negative square root of x, same thing, reflect over the x-axis. If it was negative x squared, you're also going to be reflecting it over the x-axis. Okay, so now if it was f of x equal absolute value of negative x, it's going to be the same thing as your original graph. It's going to overlap. Why? Because you're taking an absolute value of a negative number, which is going to be positive. So whether you take the absolute value of a positive number and get positive, same thing. If you take the absolute value of a negative, you're going to get a positive answer. So it's going to be the same graph as the absolute value of x. But negative times the absolute value of x is different, right? Because you're taking the absolute value of x, which is positive, then you're multiplying it by a negative, so it changes it to a negative. So the signs change. But in this case, you're multiplying, anything inside the absolute value comes out positive. So whether your x value is negative, it's still going to come out positive, hence making the same graph as the absolute value of x. So now let's go ahead and graph it and see what happens to our transformation. All right, so here we have the absolute value of x, which is going to give us a V shape starting at 0, 0. Then we have a negative times the absolute value of x. And let's see what happens. So the red graph represents our first f of x, the absolute value of x. Then the purple graph represents the graph of negative absolute value of x. And you see how all we did was reflect over the x-axis. So here we have our x-axis line, right? And all we did was reflect over the x-axis. Okay? That's because the negative was on the outside. We multiplied by a negative on the outside. Okay, let's go to our last one over here, number 4. Use the graph of f of x equal x squared, which is our parabola right here, to obtain the graph of f of x equals 2 times x squared. Okay, so here, what kind of transformation we have? Let's see, we have the only thing changing is it went from x squared to being multiplied by 2, right? So when we multiply by a coefficient, when we multiply our function, our whole function by the coefficient, we have a vertical stretch if the absolute value of a is greater than 1, or a vertical compression if the absolute value of a is between 0 or 1, meaning if it's a decimal or a fraction. Now, if we're multiplying by a coefficient on the inside of the function, we're going to have a horizontal compression if the absolute value of b is greater than 1, or a horizontal stretch if our absolute value of b is between 0 and 1. So now let's go ahead and take a look at this example. We have f of x equal x squared, which is a parabola. Then we have f of x equal 2 times x squared. I'm just going to give us a few different ones so you can see some difference. And then we have 2x being squared over here. And then we have 1/2, actually here, I'll do it here, 1/2 x squared. And then we'll do one that's 1/2 x squared on the inside. Okay? Okay, so here we're multiplying the coefficient by the function. So we're multiplying 2 times the function of x. It's on the outside. So here we're going to vertically, right? What happened when it's, so 2 here, our absolute value, if we take the absolute value of 2, it's positive, it's greater than 0. So we're going to vertically get shrink. We're going to get narrow. Okay, it's a vertical stretch. When you vertically stretch something, it gets more narrow. Now here, if you notice, the 2 is on the inside of the function, right? We have parentheses 2x squared, right? In our first problem, only x was being squared, and then we're multiplying it by 2. Now here, 2 is in the inside of a function. 2x is being squared. So when we have something on the inside, a coefficient on the inside, it's a horizontal movement. And in this case, when we have our absolute values greater than 0, greater than 1, we have a horizontal compression. meaning it gets y.